SmartKem, what do? We make a new class of semiconductor polymer transistors that are particularly used to drive the next generation of displays. We actually manufacture them as inks, so they are low molecular weight. Sometimes the inks are used as single layers, as dielectric layers. They're used to make RDL layers. Sometimes they're put into a stack, think a stack of pancakes, and etched to make transistors. And sometimes those inks are actually poured on top of existing display infrastructure that allows you to build displays in reverse. What's unique about what we do is that we make these transistors at extremely low temperatures by comparison with, and so we're talking display transistors. So we're not talking silicon transistors. So we're talking making transistors by the square yard, not on silicon disks. So today there are three major processes: LTPO, LTPS, IXO, and amorphous silicon that drive different types of displays. They're all high temperature processes, and that's very energy, uses a lot of energy and a lot of expensive material, a lot of expensive capex. Our materials are processed at less than 100 degrees, and they are all low molecular weight, so they can be used for conventional spin coating and slot die coating, and in fact even be some of them are actually being used at the moment in printheads. So in order to get a new material actually adopted, and I'll talk about materials a little bit more and what they are shortly, but it's not just enough to make the ink and then say to the world, no, here, you all use it, and this is more or less what it does, and find the applications. And we learned a lot from the silicon industry, and the silicon industry says we've got a whole bunch of new materials. In that case, it was silicon and some of the ion implantations, but you also needed to have design tools so that you can access the brain's trust of all of those people at UMass and many other universities and in all of the industrial base who want to design a circuit. And they want to use the standard design tools that are available today from people like Cadence and Synopsys. And I'll tell you what we're doing in that respect. And then you need to have independent foundry services where someone can take that design and actually can get that design made. So we're a materials company. We actually want to sell our materials to the foundry service. So in order to achieve that goal, we have to do not just generate the actual materials themselves, we have to enable people the skill sets to be able to use them, and we have to enable a third-party foundry service. So this sort of repeats what I just what I said. You know, we make inks that we sell them in bottles. You know, think bottles of well, mostly perhaps single cream would be the viscosity of them. We do sell actually single layers of our polymers. It was not something that we set out to do. We set out to just sell stacks into transistors, but we have found that they have some, you know, the low processing temperature and the fact that they are all photo cured allows people to do you know, to do redistribution layers. And somebody asked earlier about using stretchables for making multiple layers. So we can make multiple redistribution layers for PCBs. And then we have the organic semiconductors, and then we have the process, because it's not just enough to sell the materials. You've also got to you also have to develop the process by which they are used. And define and it's not enough just to say, well, you use UV light to cure them. You have to have the dosage rate. They have to work on different machines. They work at different scales, different sizes. So it's quite an effort to develop the processes. And I'll digress to a very short story.